So children, we were discussing about metals and non-metals, electrolysis. In the previous class, I told you about metals and non-metals, electrolysis. What did I say about electrolysis? This is a container in which we do electrolysis, normally called as voltmeter. Here we will take electrolyte. What is an electrolyte? I told children, electrolyte is a substance which breaks into ions when you pass current. Okay, electrolyte is a substance which breaks into ions. Let's suppose NaCl is there. If you pass current, it breaks into Na plus and Cl minus, like that. Okay, electrolyte is a substance which breaks into ions. Okay, children, when passing current, electro means current, light means breaking. On passing current, breaking. Who is breaking? Electrolyte. Now we will put one anode and one cathode. What is an anode? That which is connected to positive terminal of the battery is called anode. Anything you connected to the positive terminal is called anode, and anything which you connected to the negative terminal is called cathode. Okay, now we will keep one plugging key. Of course, we'll keep one plugging key or switch, children. If you pass the current, no current keeps on passing in electrodes and electrolyte, electrodes and electrolyte, electrodes and electrolyte, and electrolyte breaks up into ions. Okay, this is the basic structure. Okay, now using this, how do we refine a metal? This is the topic I'm going to discuss today. Using this apparatus, how are we going to refine the metal? I am showing, please all listen children, mute your audio devices. How mute your audio devices? How do you refine metal? Refine. When you get a metal, suppose children, imagine this is your copper. My pen is copper. This is impure. I want to purify it. How do I purify it? How do I purify it? Okay, children, just listen 1 second. So, how do I purify it? So, how I purify it means normally the procedure I will say. Why we are doing like that, I will say later. Always the impure copper which we want to purify, impure copper or impure metal which you want to purify, you will keep it at anode. Impure, you will keep it, use it as anode. And already existing pure metal, already existing pure metal will be there. No children, pure metal or pure copper, we will keep it as cathode. Pure metal, you will keep it as cathode. Impure, you will keep it as anode. Okay, and electrolyte, you should take same salt of our metal. Suppose I am purifying copper, then I should take copper salt only. If I am purifying copper, I should take copper salt only. I can't take zinc salt. If I'm purifying zinc, I should take zinc salt only. I can't take copper salt. If I'm purifying silver, I should take silver salt only, not copper or zinc salt. Whichever metal I'm purifying, that salt only you should take. Suppose I'm purifying copper, then I should take copper chloride or copper nitrate or copper carbonate or copper some sulfate. Any of copper salt you should take. Then you should perform the electrolysis. Okay. I hope you are able to understand. Again, I'm saying slowly. I will say, and why also everything I will say. Just keep listening. This is important lesson for you. Okay. Okay. What is this, children? Anode. What is this, children? Cathode. What is this, children? Electrolyte. Okay. So I am purifying copper. I am purifying. Imagine I am purifying copper. Refining. I mean to say I am refining copper. Impure copper, I will take it as anode. Pure copper, I will take it as cathode. Pure copper, I will take it as cathode. And here, electrolyte. What I will take electrolyte, children? Some copper salt. I will take some copper salt, like copper chloride, copper sulfate, copper nitrate, copper carbonate, your wish. Now pass the current. When you pass the current, what happens means copper means a metal. Metals will form cations in the first class only. I told how by giving electrons. Metals always give electrons and form cations. Cu plus 2 or Cu plus 1 depending upon. So copper ions will come out from anode. Copper ions will come out from the anode. Copper ions will come out from the anode on passing current because they are breaking up. And from electrolyte also copper ions will come out. From electrolyte also copper ions will come out. And all of them will go and settle on the cathode. All of them will go and settle on the cathode. You will get the why sir, why they are settling on the cathode? Because children, cations always. Cations means what ions, children? Positive ions. Positive ions, where they will go, children? To negative electrode only, no? Always always they will go to negative electrode. Who is negative electrode, children? Cathode. So on the pure copper ions are coming and settling, coming and settling. If you take 10 grams of copper, by the end of this electrolysis, you may get 20 grams of copper. Compulsory assignments, I'm just giving example. So pure copper from impure copper, pure copper from electrolyte, both of them all will come and settle on the cathode. Already this is pure copper only, no problem. So you need not to purify again. So all the pure copper will come and settle here. Why they will settle here? Because copper is a metal. Metals form cations by giving electrons. Cations are positive ions. Positive ions will go compulsory to negative only. No? That's why negative we kept a pure one. And they will go and settle. And the pure copper will be supplied here. And after all pure copper is coming here, what is left here, children? Impurities. All the impurities present in the anode will be settling down here as impurity, and that impurity, as you are getting at anode, it is called as anode mud. Now what is anode mud? It is an impurity present in the metal. That's it, children. I hope everyone understood. Those who did not understand, again I am saying, last time, please see here, children. This is copper. Okay, this is copper. Impure copper. This is what, children? Impure copper. We are using it as anode. Pure copper. Pure copper. We are using it as cathode. Okay, and electrolyte should be salt of the metal only. Copper salt only we should take. Compulsory copper salt only we should take. Now, when you pass current, when current is passed, what happens? Copper ions from anode, copper ions from electrolyte will come and settle on cathode, will come and settle on cathode, will come and settle on cathode, will come and settle on cathode. Okay, when they come and settle on cathode, all the impurities only will be left over, and copper is going everything there, only impurities left over. That impurities will be settling down here as anode mud. Okay, children. Okay, so what is anode? What is cathode? What is electrolyte? Anode is impure metal which you want to purify. Cathode is pure metal which is already existing. Electrolyte, salt of the metal to be purified. Whichever salt. Okay, I hope you understood. Okay, now for some other metal, two, three examples. I'll say this is the basic example, children. Why I'm taking anode as impure one? Because pure copper will come to cathode. Why cathode I'm taking pure one? Because this is all because pure ion always metal ions go to cathode only. Metal ions will go to cathode only. That's why at the cathode I'm taking pure one. Okay. Suppose I want to purify silver. I want to purify silver. Impure silver, I will take it as anode. Pure silver, I will take it as pure silver, I will take it as cathode. And silver salt, I will take it as electrolyte. Silver salt, I will take it as electrolyte. Suppose you want to purify zinc. Okay, impure zinc, I will take it as anode. Anode. Children, battery is represented like this. Bigger one is plus, smaller one is minus. Battery is represented like this in electricity lesson. Okay, impure zinc, anode. Pure zinc, cathode. Okay, pure zinc, what, children? Cathode. Electrolyte, some zinc salt, any zinc salt. Okay, children, understood? One more example. Suppose iron we are purifying. Impure iron, anode. Pure iron, cathode. Okay, and electrolyte should be some iron salt. Some iron salt. Your wish, children. Any iron salt like iron sulfate, iron chloride, iron nitrate. Your wish, any iron salt. But remember, salt should be same metal. When I am purifying silver, I can't take copper salt because copper will go and settle, silver will go and settle. Again, who will separate silver and copper, children? Who will separate? It is big hectic process, isn't it? That's why whichever metal you are purifying, that salt only you should take. Whichever metal you are purifying, that salt only you should take. Whichever metal you are purifying, that salt only you should take. Remember always. So finally, the summary goes like this. Last time I'm saying, children, listen. What is anode? What is cathode? What is electrolyte? electrolyte in electrolytic refining. What is anode? Impure metal which you want to purify. Impure metal which you want to purify. What is cathode? Pure metal which is already existing. Okay. What is electrolyte? Salt of the metal to be purified. Salt of the metal to be purified. To be purified. Some people will get out. Sir, pure metal. Now, first time how we got pure metal? For one metal to purify, there are so many procedures, children. This is one of the procedures prescribed in your book. We are saying there are so many other procedures like liquation, distillation, so many other procedures are there. Electrolytic refining, we are studying electrolytic refining. What is electrolytic refining? Refining means purification of metal. The electrolytic refining means by passing current, how are you purifying the metal? We are studying, that's all. Pure metal you can get by so many procedures. This is one of the procedure existing, that's all. So these 3 points, if you remember, in 8th class it will be useful. In 9th class, okay, but 10th class, this is one important question. They every year in board exam they will give this question for 5 marks with the diagram, children. Electrolytic refining of copper. Very important. 3 points, if you can remember, it's enough, children. Anode is impure, cathode is pure, electrolyte is salt of the metal to be purified. Why cathode is pure? Because all metals are cations. Cations are positive. Positive will go to negative. That's why negative we should take pure metal. Again, metals are cations. Cations are positive. Positive will go to negative. Negative should be pure metal. So on the pure metal, pure ions are settling. On the pure metal, pure ions are settling. This is the electrolytic refining of a metal. Very important question, children. Okay, this is very important.